So, we've been spending a bit of time on this, and it's really useful for us to spend time on this because we need to make sure that we know all this before we start our lab tomorrow. Okay? We're going to be working on this all week, both together and individually. Tomorrow we're going to actually look at writing an introduction. Okay, so everyone's going to be writing their own introduction. We'll give you some tips as to how to do so. Okay? Then the next day we're going to be looking at procedure and materials and setting everything up in our
Wait, what's the lab gonna be?
chemical reactions.
Okay, with
That's literally it, is chemical reactions. We are going to be observing different chemical reactions where we bring certain things together. We'll be taking qualitative observations. We'll also be looking to balance the equations from these chemical reactions, and we need to identify the type of chemical reaction that it is. So right now, what we're doing here is fabulous practice. But we're not actually making it happen. Although I'll give you a hint. Okay? You really want to make sure that you pay attention to all of these and know how this makes sense when you are doing up your lab report this week.
So I was wondering, so you know how atoms make up the
Mm-hmm.
So what would you call like a living organism? Is it made of different?
Okay, so living organisms, if we were talking about the cells that make up like plants and animals, they're going to be a combination of many different elements. Okay? And it's going to be put together in different ways. Like you guys studied a lot about photosynthesis and, fermentation and cellular respiration, right? There was compounds involved with that, right? So there was compounds in those processes, that involve various carbon and hydrogen and oxygen and so on, right? Those are things that are present in your cells right now. So your body is a lot of carbon and nitrogen and oxygen and so on. There's still also trace minerals and metals that are inside of us. Like we need magnesium. A good chunk of this periodic table is actually present in us.
Can I look at my pencil out of the fashion?
Yes. Now there's a pencil like literally just beyond your Chromebook.
Yeah. Oh, there it is.
Okay.
I thought you saw it.
But so tomorrow we start that lab where we are balancing and recognizing and seeing what these reactions look like. Okay, and so that lab report is going to be due next Monday. Okay, I'm giving you guys pretty much a week to get that done, but we're going to be spending class time on it. So let's see if we can go through these again quickly. Okay? N2, H2, NH3.
1 through 2.
I hear 1, 2, 2.
No, 1, 3.
1, 3, 2.
Yeah.
Okay, let's check. I have 2 nitrogen and 6 hydrogen, because remember that this is kind of like, if I don't have a number, we assume 1. 2 times 1, 2 times 3. So I have 2 and 6. Here I have 2 and 6. Looks good. How about the next one?
3, 1, 3, 1.
3, 1, 3, 1. Because I needed 3 chlorine here, I need 3 here. But if I have 3 chlorine here, that makes 3 potassium. So I need 3 potassium. And everything else is balanced. 1 aluminum, 1 aluminum. Okay, how about this one?
2, 2, 1.
2, 2, 1. 2 lead, 2 lead. 4 oxygen, 2 times 2. Here I have 2 oxygen plus another 2 oxygen, which is 4 oxygen. How about this bottom one?
2, 2, 1.
2, 2, 1. Let's check. 2 mercury, 2 mercury, 2 oxygen, 2 oxygen. All looks good. What kind of reaction was this first one?
It's
Synthesis. Why?
because there's one,
I see one
it's
product.
added together.
This is one product. If I have only one product, I'm synthesizing, I'm baking cake. Okay? What's this next one?
Replacement.
What kind?
Single.
Double.
Double.
No, single.
No, it's double.
It's
Right?
single, isn't it?
Oh, it's single, yeah.
I have
It's
A,
one.
B, C. Here I have A, C, and I have B. B got left out. Okay, we have a new couple that formed, and now C took one look at A, left B in the dust.
Huh.
I know, it's cool, isn't it? Single replacement. Any wonder why I start talking about couples?
Because.
It helps you remember.
Yeah.
Okay, how about this one?
Wait. You mean number 13?
Yeah. Decomposition, why?
Because there's one reactant.
I only have one reactant. If I have one reactant and it decomposes and breaks up into many reactants, I have decomposition. Hold the pickles. I don't want those pickles, and now I got to take them out. How about number 4? Decomposition again for that same reason. So hopefully you have all of this on yours. Okay, let's look at the next set. We're now at 5, 6, 7, 8. What are my numbers for 5?
4, 3, 2.
4, 3, 2?
Yeah, 4, 3, 2.
4, 3, 2. How many aluminum on each side? How many aluminum are on the reactants? How many aluminum atoms are there?
Wait, 4.
We have 4 aluminum atoms here. How many aluminum atoms on the product side?
4.
Because it's 2 times 2. Coefficient times subscript. How many oxygen? 6.
6.
3 times 2 is 6. How many on this side? 6. 2 times 3 is 6. Balanced. You know, you kind of have to imagine like we have a balance like you'd use back in elementary school where you put stuff on one side, you put stuff on the other, and we have to make sure that it equals out at the end. We're putting the same things, like if I have 2 apples over here, I have to have 2 apples over there. If I have 2 apples and 3 oranges here, 2 apples and 3 oranges there. Does that make sense? Okay, if I have a different number of those fruit, it's not gonna balance out. What kind of reaction is that? Synthesis, why?
There's one product.
One product. Okay? What were the numbers on this one?
Number 4.
Number 6.
1, 5, 3, 4.
1, 5, 3, 4. So I have 3 carbon. 1 times 3 is 3. 3 times 1 is 3. Hydrogen. 1 times 8 is 8. 4 times 2 is 8. And then we have to balance the oxygen. 5 times 2 is,
10.
and I have 3 times 2, which is 6. 4 times 1 is 4. Altogether, those are 10. So we're good. What kind of reaction is this one? No.
No, it's not, no,
It is not decomposition. Combustion. This one is your flammable. How do I know? Oxygen is a reactant, and carbon dioxide and water are products. Okay? I can have ones that have oxygen, but if there is no carbon dioxide or water, it's not combustion. If I have carbon dioxide and water, but I don't have oxygen, it's not combustion. I need to have this and this and this. Does that make sense? Because otherwise you'd think that this is combustion. Hey, there's oxygen. But what did it produce? I need it to produce carbon dioxide and water. Does that make sense? Okay. What's my numbers for 7?
3, 1, 2.
3, 1, 2. Let's check. 6 hydrogen. It's 3 times 2. 2 times 3. That's 6. 1 times 2. 2 nitrogen. 2 times 1. 2 nitrogen. Looks good. Type of reaction.
Synthesis.
Why?
Because
You're-
reactants, one product.
Yeah.
One product.
Together.
One product. We're baking a cake. Okay? 8.
2, 1,
2, 3, 1, 3.
yes.
Okay? 2 aluminum. 1 times 2, 2 aluminum. 3 copper. 3 copper. 3 oxygen. 1 times 3 oxygen. Looks good.
Is that a double replacement?
Why do you think it's double? Are we switching lab partners? Do we see like 2 new situations? What is it, Jalen? You don't know? Well, you said it wasn't double. What do you see happening? I have this guy, I have this one and this one. There's 3 different elements, right?
Yeah.
Are they paired up like this on the other side?
No.
No. We have now A, C, and B. Once again, B got left out in the cold again. Poor guy. Okay? Once again, we have a new couple that forms. That's that single replacement. We know this because we have a new single. Sadly, the world of chemistry is literally the world of chemistry, even as we see it in the regular world. Single replacement. A takes the place of B. So instead of copper oxide, we now have aluminum oxide. That's the new couple. Okay? What couples do we have out there right now? You know where they have like the celebrity nickname?
Yes.
And they merge the 2 names, like, that's kind of what's happening here. But instead of like, these celebrities, and now it's these celebrities that are now the new and latest couple. Okay, so hopefully we're following all that, although we are about to start into some new territory. Did we have 9 from Friday?
No.
Okay.
I thought we went all the way down to 12.
No, I think we skipped some.
I
Actually, no.
don't think we skipped any, and I think that we still have work to do.
Oh, yeah. I swear we went down to 12.
Well, maybe you tried to work it out on your own, because we did not do that as a class.
Oh.
We really did.
Well, maybe we
Okay.
just skip it.
So, where do I begin on this? Well, you try to avoid hydrogen and oxygen. Save those for later. So let's look at this potassium. Here I have 2. How can I have 2 on this side?
Multiply.
Just put a 2 in front, right? And that multiplies. So now I have 2 potassium here, and I have 2 times 1 potassium here. Okay? How many oxygen do I have? I have 1. Here I also have 1. How many do I have here? 2 oxygen. How many hydrogen do I have?
2.
How many do I have here?
2.
I have 2. 2 times 1.
Is okay.
Are we balanced?
No. No.
You don't think so? 2 potassium, 2 potassium, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen.
Oh, yeah.
So all I need to do is say,
2, 2, 2. Or 1, 1, 1.
why would I put 2's in front?
Okay.
If I put a 2 in front, then that multiplies this and I'd have 4.
Okay.
Would we agree?
Yes, I would.
Yeah, we do.
So if I don't have to put anything in front, all I need to do is put a 2 there. The reason why I put these here is just to say, oh, I know that all I need is one of those. I can't put a 0. I could leave it blank, because as soon as we leave it blank, kind of like this KOH, we just assume 1 and 1 and 1. We can assume 1, but I put 1s in there to say, I've done that. I know I only need one of those. Okay, but when I write out the equation, it would look like this. K2O plus H2O forms 2 KOH. So this is normally how I'd write it, but when I'm balancing, I like putting those 1s in as a placeholder.
2.
Okay? What kind of reaction is it?
Oh,
Wait, number what?
Synthesis. Why?
2 reactants.
And you're placing it together.
I have one product. I'm baking that cake.
Yeah, baking cake.
Okay? How about this one? Where would I start?
But the line.
Okay, so we're gonna start with, this is not potassium. Potassium is K. The P is phosphorus. I'm hearing start with this because this has the biggest subscript.
Okay.
So if I have 4 potassium on this side, how can I get 4 potassium on this side? Because right now I just have 2.
Multiply 2 times 2.
Multiply by 2?
Yeah.
No. It's 3, 1, 7. No, no, 7.
Okay, just be patient. So, in order for this to have 4, if we have a 4 for the subscript, so this is 4. This starts with 2. In order to get this to be 4, I have to multiply by 2.
Okay.
Okay? How many magnesium do I have now? I started with 3. I multiplied by 2, so I have a total of 6 magnesium.
Wait.
How can I get 6 magnesium on this side?
3. You put 3 in there.
Why would I put a 3? Remember, this is like 1
Yes.
times 6. This is like 6 times 1 magnesium, so I get 6. So 6 magnesium, 6 magnesium. 4 potassium, 4 phosphorus, 4 phosphorus. All I do is I put a 1 in front for my placeholder. I should have 6, 1, 2.
Okay.
It takes practice.
6 1.
What kind of reaction is it?
Synthesis.
Why is it synthesis?
100.
One product. Okay, now this looks like I have something different. What's this?
I don't
It's
know.
just, it's the,
I don't know what that means.
hold on. Give me a second.
I think she might be looking through some notes.
No, I'm not.
No?
It probably is.
What does it look like it has to do with? Why would we have an S? What could S stand for in a chemical reaction? element in water, that we've dissolved it in water. S, says we have a solid. Mr. Haddad's like, you better learn this. Cause you need to do this in his class. And much more complicated ones than the ones I show you.
Okay, it'll be easy, but.
I hope so. They're just feeling like they're beginning to get it.
No, we felt like that last week.
Yeah.
You felt like that last week?
Yeah.
I thought this is
Uh-huh.
the second day. I'm like,
So
I'm
those
feeling really tired.
are symbols, those symbols are telling
I've heard his
the
class is
element
easy.
what kind of
Very
matter.
Really?
Yeah, that's what I
Sorry,
thought. It was just
I had a
another-
hard time hearing Bella's question with all the other comments going on. What was that, Bella?
So AQ means water and then
AQ means that it's aqueous, that compound is dissolved into the water.
So how would that affect the
It doesn't.
So
why is it
so it's just there?
It's just there.
Oh, okay. That takes a
Are
while.
you gonna learn that it does something crazy?
No, never. All this is saying is I have this in water and this in water, and it forms that solid plus this action ended up on the next line. This one should be over here, but for whatever reason, because of how that's set, they put it over here.
Ooh.
Okay?
So when you're doing an experiment with these elements, would you
Uh-huh.
have to add that in?
It is just more information. It's not necessarily a requirement unless you're asked for it. But it tells you what kind of elements you're using and what those look like right now. Right? But here's something. Think about this. We have something that is right now a liquid. This is a liquid. This is a solid. This is a liquid. Could you tell me another name for this?
That would be.
That's called
When you have two liquids and you get a solid,
precipitation. Precipitation.
precip, tate.
Yeah, precipitate.
When you get a solid from two liquids, no matter what elements they are, it's known as precipitate.
Wait, so
So
yeah,
it's
water
calcium,
and water.
carbon, and oxygen.
Yeah, but you'd have to get a solid. Like you'd have to
Correct.
not just a physical change, but we need a chemical change.
What would you call that? It's calcium carbonate.
Calcium carbonate. Okay, so that's a precipitate. Let's try to balance this. It's not that bad. It really isn't. Okay? We're going to ignore this over here, okay? Just because I put it over there.
Okay.
How many, where's our big number?
The big number.
It's,
Well, we don't want to deal with
it's not
oxygen
a-
yet.
no.
We
The
can
big
either
number's
deal
in the
with
middle.
chlorine or
The
we
big
could
number's in
deal
the
with
middle.
the sodium.
Chlorine.
Let's do the
It's in the middle.
Okay, so let's start with chlorine. If I have 2 here, how do I get 2 there?
Times by one.
Times
Two.
1.
Times by 2.
Yeah,
So
two
right
times
now I
one.
have
One.
CA has 1, CL has 2. Here I had 1 NA and 1 CL, but I've multiplied them both by 2.
Oh, it's 1.
Okay?
Okay.
How about the sodium? Sodium, I have 2. Do I have 2? How about carbon?
Yeah.
1. I have 1.
I always would do.
So 2 times 1.
Calcium. Calcium.
Wait.
How about oxygen?
No.
oxygen, oxygen. Is there anything else that I need? I have calcium, there's one. Calcium, there's one.
Nope.
Nope. Chlorine, two. Sodium, I have two. Carbon, one. Oxygen, three. Is there any other balancing I need to do?
No.
It's balanced, so what do I do?
Put the things on the
One, two. What kind of reaction is this one?
It's a double replacement.
This one's a double.
Oh, yeah, I
That's
think
what I
so.
said.
Yeah, it's
Double
replace.
replacement. Now in this case, it's not just single elements, we're talking about things like this, that the CO3 is a polyatomic, meaning more than one atom, ion. So our couples here, calcium was one part, chlorine was another, sodium was one part. The carbonate CO3 acts as a unit. That acts as just like a single person. Even though it's composed of two different things. It's kind of like Jekyll and Hyde, but you know, you get the whole thing. Does that make sense?
How do you tell which is double replacement and a single replacement?
Well, in this case, what you see happening, let me use a different color. We have calcium and chlorine. So this is like A and B. And then we have Na and CO3, this polyatomic ion, it acts on its own. So we have Na and we have CO3. So we have A and B and C and D. And then they're going to switch lab partners like this. Where we start off with these partners, they're doing a lab, okay, together. But then they're like, I can't work with so-and-so anymore. So A now partners up with D, and B partnered with C.
Oh, so they're both paired up.
Yeah, they're both paired up. So even though there's a switch, no one gets left lonely. No one has to do the report on their own. Do you understand why the analogies help you to remember? Yes. Because that's what you're looking for, is what kind of relationship do these things have with each other? Am I baking a cake where I get one thing? Am I holding the pickles where I have to take things apart? Am I, getting a new date where someone gets left out in the cold, where we have that single replacement? Or do we switch lab partners and all we do is we form two new pairs? Or two things switch places. Okay? And then there's combustion, where I have to look for oxygen, that oxygen gas, O2 as a reactant on its own, and the products have to include, it can include other things, but it has to include carbon dioxide, CO2, and water, H2O.
So it has to include H2O and carbon dioxide.
Yes.
What if we have like one like CO2?
Then it's not necessarily combustion. Every example that I'm going to give you, it's going to have all of that. Okay? So let's look at 12. And let's look at 12. Magnesium, that looks pretty good. Hydrogen, I have one of those. I have two of those.
What is G?
And then Cl, Mg is the whole thing. That's Mg is the it's magnesium. H is hydrogen, Cl is chlorine. We have one Cl. Here I have 2 CLs. So how can I balance? I have to do something definitely considering I have an imbalance and I have 2 CLs and 2 H's over here. I need to find a way to get 2 CLs and 2 H's over here. How can I do that? What do you think, Christian? How can I get 2 H and 2 CL on my reactant side? So if I multiply that by 2, that means now I have 2 and 2. So hydrogen, check. Chlorine, check. Is magnesium good? 1
Yes.
and 1? Yeah. What else do I need to do? Put in my placeholders. It's balanced. Not too bad. What kind of reaction?
Single replacement.
Why?
Someone's left behind.
Yeah, someone got left behind. Magnesium formed a new couple, and now we have hydrogen left on his own. It's really sad. Okay, last few. So this one was our single replacement with our hydrogen left out in the cold. Nothing sadder than a breakup, huh? Okay. What kind of reaction did we see in 13? Decomposition.
Oh.
What kind of reaction do we see in 14?
Synthesis.
What kind of reaction do we see in 15?
Double replacement.
And then double replacement.
Is it double replacement? No.
This double replacement.
Okay. You have to learn to recognize some of these polyatomic ions. Here I have A, B, and C, D. And I get A, D, and C, B. You look for that pattern where we have 2 things switching places. If 2 things switch places, we're switching lab partners. I have double replacement. No one's unhappy in double replacement. Like everyone still has a partner, but hopefully it works even better for them. Okay? So this NO3 is a polyatomic ion. You'll notice that almost always when things are like this, what's happening is you see metal and you see a polyatomic ion that is non-metals. Metal, non-metal. Metal, non-metal. Metal, non-metal. All of these are ionic bonds that are switching.
So in 13, there's a G, the far end of
Uh-huh.
carbon dioxide.
So this is a solid, and we don't have, AQ is aqueous. What's a G?
A gas.
It's gas. Which makes sense, it's carbon dioxide. It's a gas. Okay, so let's look at 13 and see if we can balance that out. Okay, right now we have copper, carbon, oxygen. I have 1 and 1 and 3 because there's a little 3 behind the O. Now what happens if it was like this, where it was CO3, 3 inside of parentheses? How many carbon would I have then? 3. How many oxygen? 9. This would multiply here and multiply here.
Oh.
Whew. Yeah, I know. Thankfully, that's not the situation here.
Okay.
Okay?
Will that happen?
It can. Okay, on this side I have copper, 1, oxygen, 1. I have carbon, 1, oxygen, 2. So copper, are we balanced?
Yes.
Carbon, are we balanced?
Yes.
1 carbon, 1 carbon.
Yes.
How about oxygen?
No.
Yes.
No.
We oxygen.
I have 3 here,
Oh, okay. Yeah.
3 there. What do I do?
We'll just write it in the top. Yeah.
It's like, hey, this is looking pretty good. Right? Okay, how about this one? Magnesium, oxygen. We get magnesium oxide. Magnesium, 1. I have oxygen, how many? 2, because of that subscript. This side, magnesium, 1. Oxygen, 1. What do I do?
2 times magnesium and oxygen.
So I need to put a 2 in front of here?
Yes.
Why?
So you can make oxygen 2.
We want oxygen to be 2. But doesn't that change the magnesium too?
Yes. And this
Yeah.
one, 2 is magnesium. And 1 oxygen.
And so then I would have 2 magnesium, 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. What do I put in front of here?
1.
1.
Why do I put a 1?
To leave
That's
oxygen.
already.
Just to say, look, I balanced you. I know I need you. I need one of you. What would happen if I put this? Could I put a 0?
No.
That'd be like, hey, you don't exist. I can't do that. If I leave it blank, we can assume, but I think it's better that we do this, so just we know, yeah, we took care of you. We know you're there. Okay, this last one. Once again, we talk about this polyatomic ion. We deal with that as a complete unit. That can be easier for the balancing too, if we deal with it as a complete unit. Okay, so Pb, we have NO3, we have K, we have I. Here we have Pb, I, K, and NO3. How many lead or Pb do we have? 1. How many NO3? 1. How many K? 1. How many I? 1. Oh, that seems pretty simple. How about this side? Lead? 1. I?
2.
K? 1 NO3?
30. Wait.
No, just one of this polyatomic ion. We can treat it that way too. They're always going to occur in multiples like that. Okay, so I have 1, 1, 1, but I have 2. That's kind of a problem. How do I make iodine 2 over here?
1 times 2.
I have to multiply by 2, but that's going to apply to both the K and the I. So what do I do now? I need 2 potassium. I need to put 2 over here.
Times 2.
But that changes my NO3.
Oh, that is simple.
So what happens over here?
Times 2. Wait, no. Times 2. Yeah, times 2.
Oh, I'm having a problem. You said I have a problem.
Damn it.
Oh, then we're gonna do the same thing.
Okay, so now I have 2 lead, 2 NO3. What do I have over here? I have. We have an issue, huh?
This last one.
Can we start over?
Yes.
Something's not adding up.
Yeah. Like that.
I think it's 1.
Yeah, me too.
Okay, we know that our problem is right here, that we start off with, right?
Oh yeah, it's 1, 2, 1, 2. I think. Maybe.
How do you get that?
Because
Explain it to us.
just the way how y'all did it. I have it, the work is somewhere. I don't know. I just
Well, that's the thing, we need the work, like, we need to prove why it is the way it is. So, we know that we need a 2 here, because we have 2 there. 2i, 2i. This produces 2 potassium. So I need 2 potassium. I'm wondering whether I need to double check that equation. Something doesn't seem right here. Because if I have 2 here, then I also have 2 nitrate. But this means that I'd have to have 2 of there, and if I put 2 there, I automatically have more there. So something
my work is at the house, so.
something is not adding up, and I don't think that we actually have the right relationship.
I think you. Why don't you just look it up?
Yeah, honestly, it's not adding up.
In my head, last week it was adding up.
Lead,
So maybe you should just copy it. Look up the chemical equation.
honestly, this is something where it's a lot easier to potassium iodide, lead 2 nitrate.
Yeah, it's a double of this place. Ooh.
Yeah, that's correct, but Ki plus lead 2.
Then to iodine. Yeah, I'm telling you,
Okay. PB. Okay, there's where our issue is. There's our issue. Here is what's missing.
we have 1, 2, 1, 2.
Here's what's missing, guys.
I was correct.
This NO3 actually is PbNO3 with, now this is written like this. That's an actual reactant. We're missing that. That's a mistake. It should be PbNO3 with a 2 behind it.
It's still 1, 2, 1.
So that's what that looks like. Okay, so that's our issue right there, is that we were missing that. So let's try this again.
Watch me.
Okay? Lead. We're gonna start with that iodine again. Okay, 2 iodine, 2 iodine. 2 potassium, 2 potassium. That means I need 2 NO3s. Do we have 2 NO3s? Yes.
Yes.
This 2 says I have 2 of those. Lead, 1, 1.
1, 1. Okay.
Ah, I was right. Don't me.
But you couldn't explain why.
Okay, the work I had was last
It's not enough just to have the right answer.
and it was at my house.
Okay? Well, it doesn't help you if you can't explain it then. You know, I could say that too. Oh yeah, well, I know that because that's the way it is. Okay, well, why? Does it help anyone else to understand?
No.
Do you understand if you can't explain it on the spot? No,
No.
not really. And even for me, I went through and we go, oh, that's not adding up. We would be in that loop forever trying to balance it, and we never could because this was the reactant, and without that extra subscript, it actually didn't occur that way. This is the way it needed to be.
So how did you write in, the commercial field?
How would I write what?
How did you know that the NO had needed?
How do I know this? Okay, so I worked out that there was a problem with our equation, and Bella wants to know, how did I work that out? I know from looking things up that this has that charge. It has a -1. And I also know by looking up about lead nitrate that this PB was really a +2 charge. And so the only way that these two can combine together is I needed 1 of this, and I needed 2 of the NO3 that had that -1. Because I have to balance the charges. So 1 of the NO3 is not enough to combine with the PB. I needed 2 of those. And that's how I end up with this right here. Okay? It's a matter of, this was an ionic compound, and I needed to balance the charges. You're welcome. So make sure that you guys get this in because we start a lab tomorrow.